So today I want to talk a bit about how UR maintains our ROS driver, how we do that, the challenges that we face with that, and my motivation for that is kind of twofold. So first of all, for those who maybe do want to maintain their own ROS packages and seek for advice on how to do that, I'm not saying that I'll kind of give a reference point for everything, but more of this is how we do it. And the other point is that I would like input on that. So if you do things differently, if you're questioning things the way we do, I would love to discuss on that, so more on that later. So just to give you a brief history of where we come from a ROS perspective, I mean, you know Universal Robots probably, we do these robotic arms. We were founded back in 2005, and the first product was launched in 2008. And 2012, there was already the first ROS package. That was community contributed, so it was mainly developed by Willow Garage and the IPA actually back then. And since then, we've come a long way. So back in 2018, kind of started developing a ROS driver in-house, or back then it was done by the FZI Research Lab, but done or contracted through UR. And then we launched the first driver in 2019. Then the ROS-2 driver came later on in 2022. And the latest thing that we have is PolyscopeX, which I'm also going to talk a bit more later. The context why I bring it up here, PolyscopeX actually has ROS-2 built into the robot control. That's our first robot that has it built into the controller next to Docker, but more on that later. At first, I want to talk a bit what we've done recently in the ROS driver. So one feature we're really happy that we finally released it is direct torque control. We now do have joint torque control directly available. So this is the functions that are available in URCapX, the scripting language that is used for Universal Robots, with all the different functions that are available. But of course, we're at a ROS conference and we want to have that in the ROS driver as well. We had our customer, NVIDIA, who did a demo back then where they did the transfer of learning task in simulation and then putting that on the real robot using the new torque control. Currently, that's available in the ROS driver through an effort interface, so all of our joints now have a position, velocity, and the effort interface, and that obviously can be used through ROS-2 control with any controller that is capable of using effort interfaces. Currently, we package the joint group effort controller with it, but obviously you can combine that with any controller that uses effort interfaces. We know that a lot of people want to do impedance control, especially if they use machine learning, where there's a policy that learns on how to do something. You often have like lower frequency target positions that you would like to have some compliance when executed, which is why we're also working on impedance control, where we currently go the path of implementing that more on the robot controller side, because we're just much closer to the controller cascade than any ROS controller would be, with then exposing a position interface out to ROS. But that's currently still in the process of being done. One other really cool feature that we recently launched is the motion primitive controller. For those of you who are more on the kind of traditional automation side, you're used to commanding your robot in point motions, linear motions, circular motions, and so on. While in the ROS world, we usually more think of a more complex trajectory where we pre-generate the whole trajectory and then that gets fitted as a spline representation, and then we have this high-frequency target command sent down to the robot. While that is working for many robots and has been working for many years, we also see a lot of upsides of doing it another way. So if we would send the whole trajectory in advance to the robot and leave that for interpolation, we would not, we kind of reduce the requirements for the real-time control, real-time communication between the ROS PC and the robot controller. And actually, as a robot manufacturer, we do put a lot of effort in making our motions as optimized as possible, while traditionally in the ROS world, we kind of tend to throw all of that away and say, well, just give me a raw interface. Whatever you do for optimization, we don't care about that. And so the motion primitive controller is kind of trying to go somewhere in between, where you can then execute sequences of these more traditional motions, send that to the robot driver, and then that gets sent down to the robot and executed by the robot controller in an, we hope, as optimal fashion as possible. That has been implemented by Matthias at Be Robotized as a master thesis. We were involved in reviewing that quite a lot. And Dennis and I am going to do a ROSCON DE talk on Wednesday, so if you want to know more about that, please have a look there. So, maintaining a stable ROS ecosystem. First of all, what do I mean by the ecosystem? We have a lot of ROS packages, so to say. So this is kind of parts of our nightly build jobs. It's a quite diverse system, right? We have 12 different robot models. We have 3 different platforms. We have currently 4, maybe 5, depends on how you define it, ROS distributions that we support. We have about 10 ROS-II packages. We have 8 different control modes, but all of that is packaged into one ROS driver. And by the way, if you think like, hey, there's jobs red, that's not good, that's intentional. More on that in a second. So when we talk about keeping and maintaining that in a stable fashion, what we see is more or less these 4 main challenges that I want to talk about today. So we have different ROS distributions, as I mentioned already. We have the challenge of documenting everything, that it's available for everybody and as complete as possible. We have a robot and control mode diversity kind of, and we have an ecosystem which is kind of agile by definition, right? We want ROS to be innovative as much as possible. We have this rolling distribution that has its challenges on its own. So let's start by the different ROS distributions. As I mentioned, we currently support 4 different ROS distributions, the ones that are live, and you see down there, I don't know whether you remember, good old Noetic. We do still have the driver there, and we also put some new features in there, though it's not as well maintained as the ROS-II distributions, obviously. So how do we handle all of these different ROS distributions? So our main approach to that is to have a common branch for all the distributions as long as possible, and only branch off when it's really necessary. That's why sometimes we get questions, why do we release our interfaces packages from a Humble Devil branch? Well, that's because there was no changes in Humble on the interface level, there was no need to actually create a new branch. And that gives you the easiness that whenever there's something new coming in, you don't have to backport that to other branches. And that's the strategy that we use for things where we do break. We use the tool called Mergify for backporting things to the other development branches. So that comes in quite handy. And doing that and keeping things as much backported as possible also makes it easier for when you do changes in the future, if your code base in the former branches matches as closely to your development branch as possible. And obviously, when you do break things, it's important for users to see those changes. What do they have to do if they go from one distribution to another? And that might be relevant. You might think of, well, we document what you have to do when you go from Humble to Iron, for example. But then maybe somebody goes from Humble to Kilted, and so they have to have all of the changes accessible from all the different distributions in between, which brings us to the next point, which is the user documentation. We have, as I mentioned earlier, we have like these plenty of ROS packages that are distributed over 5 repositories, and obviously they all have their individual aspects that need to be documented. So there's different approaches to that. While you could keep the different documentation completely separate, that would make it more easy from kind of a maintenance perspective maybe, but what we think is that having your documentation really close to the code, so whenever there's a code change, we can require developers to actually update the documentation as well. That's the main benefit of the strategy of keeping documentation in the repositories individually. And then we have like a top-level repository where we assemble all of that in one common documentation that is then hosted at doc.universalrobots.com. And just to say that the strategy for that, a lot of the mechanisms, we have got inspired by the ROS-II control project. So control.ros.org is also quite nice documentation in my point of view, where they do kind of the same thing, just as a side note. One challenge with that is obviously, as we do keep the individual documentation in the repositories and the packages, the build farm also does the doc jobs and then renders only the packages from the documentation from that respective passages, where if we do have cross-package links, that doesn't work quite well for that. So maybe if somebody wants to discuss something on that, I'd be happy to. As I mentioned earlier, we have a lot of different robots and with different platforms. We currently support almost all of the robots that Universal Robots has sold in the past. So we have back then the old CB3 robots. I guess many of you know those still. PolyscopeX is probably Polyscope 5 is the one that most people are familiar with. And then we have the new PolyscopeX. They are all a bit different in a way and have to be treated individually. But all in all, we support all of those things from the same branch. And while that gives a lot of workload up front often, to make sure that if we develop a new feature, it has to work on these old versions that we do not officially support from UR on the robot side anymore anyway, but still we have to make sure that that works on those. And what helps us there tremendously is having a simulator that's kind of as close to the robot as possible. So we run a lot of things really in CI. You see kind of a matrix down there. Every night we run our master branch against like the CB3 version, the oldest supported Polyscope 5 version, the newest, and the same for PolyscopeX, just to make sure that everything is running with all of the different versions. And it's not only our robots that are a bit diverse, and it's also not only the ROS distributions that are diverse, but also the DOS distributions themselves change a lot, especially rolling, right? I don't know how many of you develop packages using rolling. It's kind of a challenge on its own. It can happen, it's happy Monday morning, you come at your desk and you see all of the CI jobs are broken because ROS2 control just did a change again on the weekend. Happens quite often, so how do we deal with that? One way would be to say, well, they just do their stuff in rolling, and whenever things get stable, for Jazzy, for example, then we do that. A lot of people do that, and that's fine. However, going with the changes on rolling has a couple of advantages, in my opinion. First of all, you kind of are ahead of those changes. If you would wait for changes to come in for the next ROS distribution release, there might be a ton of changes that you had to adapt to. And then you have like this challenge. There is kind of a deadline when there's the new ROS distribution coming out, and then you have to make your changes ready until then. If you just keep updating things as they come in, you kind of do have more time to adapt to those changes, right? And so how do we deal with that? Is again, we have a kind of multi-stage pipeline, which looks a bit weird at the beginning. And as I said earlier, we had like this red jobs, and I said, well, that's fine. It is, because we have like these different, these are all running the same software, so the same master branch of the repository, and we have down there the build farm jobs, so that's the packages built by the build farm. As long as the build farm is happy, we get binary releases, great. The more important ones are the top three. So we have the semi-binary builds, binary testing, and binary main. First of all, just I don't know whether you're familiar with the release process of ROS packages. So as soon as you release a new version of your package, that gets picked up by the build farm, built into a Debian package, and then that gets pushed to this so-called testing repo. And then any other build job picks up that as a dependency if it depends on your package. And then there's these syncs that roughly happen over every 4 weeks. And that's when things get synced from the testing to the main repository, and then they will be available for the end users. So if any project makes a change, so let's say an upstream project makes a change, that first of all lands on their development branches. That's when the semi-binary build picks that up already, because the semi-binary builds a couple of selected dependencies from source of the upstream workspace, so that we build our master branch against the upstream dependencies master branch directly. As soon as it lands there, it ends up there. So if any breaking change ends up there, that job will turn red. So that gives us a notification that there is something we maybe need to change, but that's not going to affect any end users as long as they do not choose to build from our master branch directly. If they choose to do so, fine, but that's the risk that you take with that. And then when this upstream package releases their breaking change into the build farm, that's when the development job might turn red. So we can then adapt to that, and when we adapt to that change, we see that our package builds fine with a released version in the build farm. So that then means if we would release that stage into the build farm, then our build farm jobs will hopefully turn green again as well. And while the main job is currently red, and I say that's fine, you could think, well, if the main job is red, that's not good, right? But obviously, if you do changes that require changes that are not yet synced, as in this case, that's kind of the torque control changes that we have added to our client library that are not synced to the main repositories. That's why the main job is red, but that's fine, because we know as long as the testing builds are green, we know that with the next sync, the main job will turn green again as well. So, as I said, we have PolyscopeX as well, which has ROS2 built into the system. So what do I mean with that? We have the ROS-2 driver, the left side that we've been talking about so far. That's what most people are probably familiar with. But we also have the native ROS support on the robots control box, where basically we don't need any driver or anything. We have the control box communicating with an external ROS node directly using the ROS protocol. So what you can do with that is, for example, you can have a ROS subscriber directly in script code. I will not go into detail there. My colleague Mihal has been talking about that last year, and there's also the online documentation. So if you want to know more, just have a look there. But what's even more important in that context, maybe also for this presentation, is with that ROS integration, you can use that as a communication layer on kind of every level of your application. So we have this system that we call URCapX, where you can package your application code into a custom solution that people can install on their robots. So for example, if you have a bin picking solution, if you have a palletizing solution, something like that, you can package that and then people can install that on their robots. And we encourage people to use ROS-2 as a communication layer with that. So in the end, things will be running in Docker containers. And so people can use ROS to communicate between their front end and their back end, between their back end and the robot controller, and so forth. And while that is really cool, and especially we as ROS enthusiasts think, well, yeah, let's get ROS to more systems, that obviously also comes with a couple of challenges, so to say. So what do we do if we have to update our operating system on the robot? That even gets more relevant in terms of cybersecurity, right? When I've been talking about that, also that it's a very important aspect. We have the Cyber Resilience Act coming into action pretty soon. So there definitely will be a point where we will have to update our operating system. So we have to make sure that the ROS distribution that comes with that is compatible with that operating system. And if we have to update the ROS distribution, what does that mean to our end users and all of the URCapX suppliers? Because a breaking change in the ROS distribution might be not compatible, as we've seen with the Humble to Jazzy change. Who's been affected by that and knows what I'm talking about? Not too many. Okay, so there was this kind of discovery message incompatibility, so that as soon as you had a non-Humble node running on the same network, on the same ROS domain as another Humble node, that made the Humble node just basically eat up all of your memory in a matter of seconds, which is not great from a cybersecurity perspective, obviously. And so that's why we try to push towards having that kind of long-term support in mind also with that regards, so that while ROS usually pretty strictly states we do not support cross-distro communication, we think it's also important to make sure that there is no cross-distro destruction, so to say, right? So that's something we kind of try to go a bit, to engage a bit in. So what I think having ROS support in the controller as well as on the robot driver just gives users kind of flexibility, what they want to do. We've done a ROSCon talk in Singapore a couple of weeks ago that goes a bit more into those details if you want to know more. But on the other side, like having features or making features available in this kind of distributed system where there's all of those possibilities makes it a bit slower to get new features in. As we've seen with Tor control, we've added that, I think, back in September, and it's still not available in the main branch because the process takes a bit of time, which goes into all of that I've said earlier, making sure that everything works with all the platforms, all the different ROS distributions, just makes things a bit harder than going from this, okay, it works now, until something we can release is a long way. And that's a lot of effort we put in up front to make sure that it does work everywhere, but I think it's definitely worth it, and that gives you the kind of less maintenance in the end if you make sure that things work up front. So that's all I have today. Thank you for listening, and also thank you for all of the great work in the community. It's been a great time so far, and hope we get a lot done in the future as well. Thank you.